Hello, welcome to the video series for Geography 300, Geographical Data Analysis for West Virginia University, Spring 2021. This is the first of what will end up being quite a few different videos. The goal here in this video is a very broad, big picture overview of the process of geographical or spatial analysis. We'll be, in a way, revisiting this process throughout the course of the semester, and we'll see how it pertains to different steps along the way. So, and it is, if you are getting the resource textbook that I mentioned, if you're going through with that, it is based upon figure 1.1 in that book. So this process has many different steps to it. The first one is identifying some kind of problem. So in terms of an example, this is usually pretty generic. It's kind of the motivation for what you want to do, a very big picture goal for the analytical project. So to take an example from what we have been dealing with for approaching a year now, we can have as a goal understanding some of the dynamics about COVID. So why do some places have a greater rate of COVID infection than others? This is, say, for a public health agency, this is the task or the goal that we wish to complete. The next stage is to get data. Obviously, we would need the COVID rates and how those have changed over time, most likely. We would also want to have some information on things that can affect the rate of COVID. In many cases, this is where we would draw upon knowledge from either from things we've done before, from other people, getting a greater background knowledge. And just in a regular classroom setting, I would have the entire class brainstorm and fill up some of the different other data sets. I'll just list a few here. We might say whether or not mask mandates affect compliance, so affect mask usage. So whether or not a county or a state or a town has a mask mandate. Next, as an infectious disease transmitted through the air, something that could increase transmission rates would be a higher population density. This isn't guaranteed, but it's a possibility, so we could collect that data and include it. A third potential factor that may affect this could be recognizing that as a airborne lung-based disease, that perhaps air pollution can affect people's immune systems, can affect people's respiratory systems, and make it spread more efficiently. So we can have here just a set of data to work with. Once we have our data, the next step is typically to describe the data, to find out what's in it. You collect it, and then we want to poke around and see, okay, what's going on here. This is where the part of statistics called descriptive statistics comes in. They help us summarize and understand the data a bit better. This could take the form either numerically, so things like to say, okay, what is the average, or what is the variation in the COVID rate, in the pollution levels. It can also be visual. So we might have a chart of population density or a graph. And we can also map things out. So we can map out the COVID rates. We can also map out where there are and are not the mask mandates. Once then we have our data described and we have a better understanding, and we take a look, we then in a way revisit this problem to then come up with a more specific, more precise hypothesis. This hypothesis then is a very precise question based upon that problem, informed by both our background knowledge and informed by the data that we have described, to come up basically with a yes or no question. It's maybe not guaranteed that it must be yes or no, but most of the time it is. So a yes or no question that gets to one aspect of this problem. An example here so we might have as a specific hypothesis, we can either put it as a question here, are COVID rates lower in places with mask mandates? We would actually in many ways rephrase this, and when we get to more detail on inferential statistics, we'll see why it's phrased this very specific way. We would put that as a statement. COVID rates are not lower in places with mask mandates. It might seem odd to you that we're phrasing this basically in such a way that we actually kind of expect the other to be true. We expect it to be lower. It's phrased this way as I said, when revisiting inferential statistics later in the semester, we'll see why. This is setting up a relationship between two variables. This is often what happens with our inferential statistics, with our hypothesis, the relationship between COVID rates and mask mandates. Two things. And we normally formulate our hypothesis in such a way that we state it so that there is no relationship between those two. So, in a way, this is saying, my first argument here is that mask mandates have no effect on COVID rates. And we set out basically to disprove that hypothesis, and thereby conclude that yes, they actually are effective. But for now, we formulate this hypothesis, then we test it. You don't need to know why I made this choice. We would then pick a statistical test to evaluate this hypothesis, to tell me what is the probability, sort of, what is the likelihood that the data supports this hypothesis. In this case, the choice would be a t-test, comparing the COVID rates of places with mask mandates versus places without mask mandates. That t-test will tell us how likely it is that the data supports this hypothesis. The last step, and that gets to this course, Geog 300, being a speak right course. We don't just stop once we have evaluated our hypothesis. The questions that we ask, everything in kind of the real world scenario or setting is in service of something else. There is something motivating this initial problem. And typically, other people are interested in the results of that. Not always, but typically. So we would then take these results and provide a report or a recommendation to a local public health department. And if this analysis goes the way we would probably expect it, you might then say to a public health department, we recommend that you advise city council to impose a mask mandate. That is then taking the results of the analysis, bringing it back to society, bringing it back to policymakers, communicating the results to them in a way that they can use. This is a nice, neat presentation of this process. It is just as important to note that in many cases this is iterative, where you get your results, and one thing that you may do is to say, oh, I actually need more data to better understand, to better answer this problem. And then you go back to an earlier stage and continue on with the new data. So there is, in many cases, a back and forth throughout this process. But here is kind of the standard process for conducting an analysis. Really, in a way, any statistical analysis, not just a geographical one, but it works for this course as a means of spatial analysis. So, if there are any questions, please feel free to email me to ask about this during our in-class Q&A session, and I will see you at the next video.